Hi and welcome to this video on Introduction to Numpy Arrays. Hi, I'm Raghavendra, an expert in AI, ML and data engineering. By the end of this video, you will be able to learn how to create an n-dimensional Numpy arrays and subset a Numpy array. You'll also learn how to perform some math operations on a Numpy array. Let's first import the Numpy array. Here is the command to do that. From Numpy, so I'm just going to say import Numpy as np. So first I start off with a list of numbers and I say np.array. Array is a function from the Numpy module. I say np.array. I pass this list as an argument to the array function. I get a Numpy array. I save it in object A and let me print it out. Here I have a Numpy array being printed. Let me check the type of the array. Type of A. You're going to get numpy.nd array. It's an n-dimensional array. So in a Numpy array, all the elements should be of the same type. Suppose I want to perform an operation like multiplying every element by 10. So I have a simple operation on a Numpy array as simple as A multiplied by 10. This multiply by 10 is going to be applied implicitly on every element of the Numpy array. So let's execute this. Here you can see every element of the Numpy array is multiplied by 10. So that's the very simple way of applying an operation. So this is called as vectorization. So implicitly applying some operation on every element of the collection. So now let's perform another operation, A greater than 50. The condition greater than 50 is going to be implicitly applied on every element of the array. So first on the first element, that is 10 greater than 50. 20 greater than 50, 30 greater than 50 and so on. So that operation is going to be applied and when executed you are going to get a Boolean array of true or false, though for those numbers which are greater than 50 and false for those numbers which are not greater than 50. Now let's put this condition A greater than 50 within a subscript and let's try to subset a Numpy array through this condition. A within square bracket, I specify this condition A greater than 50. So let me execute it. You're going to get numbers 90 and 100 of this subsetted Numpy array. What do you mean? So we have conditionally subsetted the Numpy array, which means that we are going to filter out elements of the Numpy array which satisfy this condition A greater than 50. Only those elements which satisfies the condition. So here, unlike our traditional collections of lists, tuples, we can also subset an array by specifying a condition through the subscript. So moving on, let's look at the shape of the array. A dot shape. Shape is the property of an array. We are going to get that out. It comprises of 6 elements. Let's check the dimensions. A dot ndim is going to give you dimension. It's a one-dimensional Numpy array comprising of 6 elements. Now let's pass a list, in fact a heterogeneous list, into the array function. np.array, we pass a heterogeneous list. Let's see what happens. An array traditionally is a homogeneous collection of elements, but when a heterogeneous list is passed, what happens? You can observe the array auto-coerces all the elements to a single type. So now you can see all the elements are of string type, right? Now let me take another example where we have numbers and Boolean values converted to an array. Now all the elements are numeric in nature. So true gets converted to 1, false gets converted to 0 and so on, right? So all the elements are auto-coerced to a common data type. So we can as well create a two-dimensional array. So I have a list within a list here. I have a list 1, 2, 3 and 4, 5, 6 and these two are within another list. So I call it as D. So moving on further, a list within a list passed into an array function is going to give you a two-dimensional array. So let's create an array of 2 dimension. Let's check the dimension. D of endim is going to give you the dimension. D of shape is going to give you the shape of the array. Here you can see D is 2-dimensional and comprises of 2 rows and 3 columns. Now Numpy arrays can be generated using arange function. np.arange of 5, np.arange of 1, 10, np.arange of 2, 10, 3. Let's check the output. Arange of 5 is going to give you numbers from 0 to 4. Arange of 1, 10 gives you numbers from 1 to 9 excluding 10. Arange of 2, 10, 3 is going to give you numbers from 2 to 10 excluding 10 in step of 3. So 2, 5 and 8 are the numbers of the array. Likewise, if in case you want to initialize your array with ones or zeros, so you have np.ones function, np.ones of 4, np.ones of 2, 3 and np.ones of 2, 3, 3. Let's see what happens. np.ones of 4 is going to give you a 1-dimensional array of 4 elements. np.ones of 2, 3 is going to give you a 2-dimensional array of 2 by 3 matrix, all comprising of value 1, and np.ones of 2, 3 is going to give you a 2-dimensional 3 by 3 matrix, which in fact is a 3-dimensional array comprising of all values being 1. Likewise, you can initialize your Numpy array with zeros. You can either have a 1-dimensional array of all values being zeros. You can create a 2-dimensional matrix or 2-dimensional array of all values being 0, and you can even create a 3-dimensional array with all values being initialized to zeros here. So these initializations are very important before you perform some of the mathematical operations. Let's now perform some mathematical or statistical operations on a Numpy array. Let's create a Numpy array. I can find the sum of all the elements using sum method, x.sum. You can find the product of all the elements using x.prod function. You can find the minimum using the min method, minimum of all the elements, maximum of all the elements, right? x.max, x.mean is going to give you the average, x.cum_sum is going to give you the cumulative sum of all the elements, x.std is going to give you the standard deviation of all the elements, np.median is going to give you the median among all the elements of the Numpy array. And at times you might not be interested in finding out which element is minimum or which element is maximum. Rather, there are some use cases where you would require to find out the index of the element which is minimum or index of the element which is maximum. For that, we have x.argmax is going to get you the index of the maximum element, that is maximum element is at index or position 4, and the index of the minimum element, it is at index or position 0. Now moving on further to subset a Numpy array, let's take another Numpy array as an example. So you can slice a Numpy array using the colon operator. This code is going to get you the elements at index 0, 1 and 2. So 3 is the exclusive index. This array of -1 is going to again give you the last element. Right. So array of 0, 6, 2 is going to give you elements from 0 to 6 excluding 6 in step of 2. Right. You get elements 10, 30 and 50, alternate elements till index 6 by excluding the index 6. This interesting piece of code over here, the array a1d of ::-1 is going to display the array in the reverse order from last element to the first element. So we take another two-dimensional array A to D comprising of 2 rows and 3 columns. A to D of 0, 1 is going to print 20. 20 is nothing but the first row second column value. That is what your 0, 1 stand for. A to D colon 2 is going to print all the elements from the third column, that is 1 and 75. A to D of 1, colon is going to print all the elements of the second row. Let's now take a simple subsetting task where we have a two-dimensional Numpy array and we'll have to subtract every element from the mean, and we will have to find out all these elements of the two-dimensional Numpy array which are below the mean. So here is the Numpy array which we are creating. Let's compute the mean. np.mean of the two-dimensional Numpy array is 20.166. This operation is going to implicitly subtract every element of this Numpy array by its mean. So A to D, every element of this array is subtracted by its mean. So the first element 10 minus 20.166, 20 minus 20.166, and so on are the values when subtracted from the mean. So this accomplishes the first task. The second task is to find out all the elements which are below the mean or lesser than the mean. So this operation is going to give you a Boolean vector or a Boolean array. So true at places which satisfy this condition which are lesser than the mean, and false at places which are not lesser than the mean. So when I put this condition inside the subscript and subset the array, so let's see what happens. It's going to give me all the elements which are below the mean or lesser than the mean. You can observe all of these elements are lesser than the mean value of 20.166. So the key takeaways in this video are: Numpy array is a homogeneous collection of elements. Numpy array allows vectorized operations with requiring of no explicit for loops. A range function of Numpy generates a sequence of numbers to form an array. Sum, min, max and other mathematical functions can be applied on the elements of a Numpy array. Thank you.